Welcome back. In the last session, we have defined the architecture of our LSTM network. So, short reminder. We have defined the input layer and we have defined two LSTM layers and output dense layer. This is, at the first sight, a pretty simple architecture. So we have four layers which are connected with each other, as we know from another neuronal networks. So they are connected as dense layers from input to the output. But now let us have a look at LSTM layer. So for the to reduce the complexity, let us assume that our layer will consist only of one node, just for explanation reasons. So now we are looking at one layer which has one node. So let's have a look. This is the picture which I have copied from the homepage of the Redwood Center for Theoretical Neuroscience. This is a center of Berkeley University, and this is a blog of Brian Cheung. Now, what do we have here? You will see here a timeline. So here you see 7 time steps. In our network, we have 10 time steps, but you can imagine, so we can add here 3 additional time steps. Now, we have here input layer, denoted as inputs. We have here hidden layer, and we have output layer, outputs. This is the same architecture as we have here. We have input layer, we have LSTM layers, but now we think only of one layer, and we have here output layer, which is the dense layer. This is the same architecture. But what we see here is that the LSTM layer is unrolled in time. What does it mean, unrolled or unfold in time? It means following. Those are all copies of the same LSTM node. Here we have 7 copies. In our case, we would have 10 copies. So the LSTM creates for every time step a copy of itself. And this hidden layer, which has only one node, in our case, we have reduced it, in fact, to one node, but it can have much more nodes, let's say 10, 20, 40, whatever you like. But here, to simplify the whole story, we think of it as of one single node. So for every time step, the LSTM creates, as I said, a copy of itself. How data flows. So we see here that the data on the input node at the certain time step, here for example 1, 2, 3, 4 and so on, flows to the hidden layer. And here you see this signs, this circle and this minus signs. This signs denotes to so-called gates or valves. In the next explanation, we will see what the valves are. But now, just think of them as valves. So here you see a cycle, an open pipe. If you look at the first time step, you see that the data can flow through and arrives this black node in the hidden layer. Then you see a kind of minus sign and the data is blocked here. It cannot flow to the output. Now we are talking about the first time step. Let's have a look at the second time step. The information flows from the input to the hidden layer, but again it's blocked here. If we look at the path from time step 1 to the time step 2, we see that information can flow. So this valve at the second time step is open, so the information flows there. Then it flows to the time step 3, then it flows to the time step 4, and only here the valve which allows to flow to the output again is open. So now have a look at such single node at one time step. Anatomy of an LSTM node. So we have seen this is the same picture as above. Now what we have here explains a lot. Also what we have talked about in the previous sessions. You see here cell state and hidden state. This is very often confused by people, but here I find this explanation is very clear. What we have here cell state. Cell state is actually just in a memory. This is the state of the LSTM node memory, which is within this node. This cell state or cell memory is surrounded by 3 gates. One is the input gate. Input gate is the valve which controls the information flow from input to the cell state. So this is the valve, or this is a gate which can let in the information to the cell state or block the information, not allowed to pass this valve. So you can see here only at the first time step the information can flow to the hidden layer. Now we have the forget gate. This gate stands between different time steps within hidden layer. So all those, if you look at the hidden layer here, you see the cycle to the left. This is the valve, this is the forget gate. So here it's open at the first time step, in the second time step is it open again, in the third open, fourth open, fifth open, sixth open, but seventh is closed. So the information cannot flow from the sixth time step in the within hidden layer to the seventh time step. And now we have output gate or output valve. This valve controls the information flow from to the outside, to the output. So you see here output layer. For every time step you produce one output here, and you see the information at the time step 1 it blocks here, time step 2 again block, time step 3 blocked, time step 4 open. The information can flow to the output. And this is this output is hidden state. Why it's hidden? What is hidden in it? So actually, okay, it refers to the output of the hidden layer. Hidden meaning this is the layer which lies underneath of the input. But there is more about this hidden, to be hidden. This information accumulates a lot of processes which are happening within time. So the whole flow of information from time step 1 to time step 6 is reflected in this output. So we have here one open gate. We see here output gate is open at time step 4 and at time step 6, but what the network is outputting here is the result of processes which are happening in the time steps before that, and this is the one of the reasons why it's at hidden state. So this is the short explanation. So just remember the main thing is here that the cell state is the memory state. This is the inner cell of the state. It is not always passed to the next layer, and we see here, since we have defined a stateful LSTM, so we have set stateful true, it returns sequences, and it's also per default returning state, cell state. Why? We have said that the batches are the training units, and after one batch is completed, the next batch is initialized not with zeros as the case with stateless neuronal networks. It's initialized with the hidden state and the cell state from the previous batch. And this is what we have to remember. Now, if you would like to know more or more in detail how it works, I mean every single gate, how it's computed, and so on and so on, it's all described very well on internet, and there are several great articles out there, but I would recommend that you should look at article of Kola's blog, and it's really great article and good reference. So with this, stay tuned and enjoy our sessions. See you. Bye bye.